Video number 133, Simplifying Radicals. Now before we step up to the plate here on these, although this is a really easy first one, as you can see they get a little bit goofier as you go along. We're going to take a look at simplifying radicals, the way I like to teach it, and the way I have found that my students find to be easier than the way it's being taught at most of the junior highs and high schools. First of all, here's a list of perfect squares, okay? Here's a list of perfect cubes. This can be generated just by your own mind. 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, and on and on and on up to 15 squared. These are very memorizable too. I come to find that most students have up to 10 memorized. A lot of students have 11 squared and 12 squared memorized. They get stuck over here, which, look at the numbers. 13 squared, 169. 14 squared, 196. So you can easily memorize the first 15. It's not a big deal. I don't care what level of mathematics you're in. I don't care if you're a third grader in a low-level class. You can memorize these perfect squares. Now, what we can do here is we can use these perfect squares to help us simplify problems like this. For example, square root of 44. You take a look at the number 44 and see if it has any of these as factors. Does 44 divide by any of those? And yes, it does. It divides by 4. So we would then change this to root 4, root 11. This is not hard. And then the next step, we all know that the square root of 4 is 2. So we'd literally write down the number 2, and then we put the square root 11 right next to it. This is not difficult stuff for our students to do. Here's another example. What about square root of 72? Let's just jump right into some of the more difficult ones. Again, we would refer to the list. And a lot of students would see that 9 divides into 72, and they would put down root 9, root 8. However, be careful. Anytime 9 works, always check to see if 36 works, because doesn't 9 go into 36? Okay. Same thing with 4. What we really should have done in this last one is when 4 works, you want to check to see if maybe 16 works as a factor. And it didn't, so that's why we ended up with a successful answer. So we would then notice that since 9 works, okay, let's try 36. It does. Of course, root 72 equals root 36 times 2, and you would get 6 root 2, and you're all done. Okay? Here's another one. Square root 75. Well, take a look at the list. 25 divides into 75. If 25 works, check to see if 100 does. Of course, when 100 does, it's usually pretty obvious. And 100 does not work, so we'll put down root 25 times root 3, 3/4, so 5 root 3, and you're done. This is the easiest way that I've come to find for my students to be successful in simplifying radicals. The way that this is taught in schools is the teachers have the students do a factor tree, and they have them put down 25, 3, 5, 5, and then they write down 75 as written down as 5 squared times 3. This just complicates things. Our students understand the square root of 25 is 5, and if they don't, it should be taught. Instead of trying to teach students as if they don't know how to multiply, why don't we teach them how to multiply instead? That makes matters a much more easier for them in the long run. Now, there's also simplifying perfect cubes. For example, the cube root of 40. And here's one of the more basic ones. We would then take a look at a list of our perfect cubes. Okay, here are the squares. Here are the cubes. Now, how do you generate a list of cubes? 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 squared is 120. 5 cubed is 125, 6 cubed is 216. This is rather simple to do, and you're all set. Again, same strategy. You take a look at 40. Does it divide by any of those? Oh, it divides by 8. How many times? 5 times. So you put down cube root of 8 times cube root of 5, and that gives you 2 cube roots of 5. It's that simple. No big deal. Let's try another one. How about the cube root of, let's do cube root of 500. Cube root of 500. Well, what students may get stuck doing is they may call this root 5 root 100. A better way to go is to take a look at the list. Does 8 go into 500? Probably not. 27, definitely not. 64, no. 125, yes it does. 125 goes into the 500 4 times. Okay, now, what's the cube root of 125? 5. So the answer is 5 cube roots of 4. This is not difficult to do, and it's something all of our students can accomplish. Let's take a look at our video printouts here off of Microsoft Word. Square root of 36 is 6, and the reason is because 6 squared is 36. Okay, so this symbol squared and square roots are inverses of one another. Alright, next one. Square root of 81, x to the 6, y to the 9th. What you're going to do is we're going to rewrite this. You're going to rewrite this part here. This is still y to the 9th, isn't it? Now, why are we doing that? The reason is because y to the 8th, the cube root of y to the 8th, could be rewritten as, square root of y to the 8th, could be rewritten as square root of y to the 4th squared. This is still y to the 8th right here. Now what's neat about it is you got your square root and your squaring inversing each other out. So therefore, you're going to end up with just simply y to the 4th. That's why this becomes y squared. X squared. Because your x to the 6th could be done the same way. So square root of 81 is 9. Square root of x to the 6th is x cubed. Square root of y to the 8th is y to the 4th. And you're left with an extra y. There you go. There's your final answer. That easy. Next one. Cube root of 1,000 is equal to 10. And I put this here just so we can remember that the reason is because 10 cubed is 1,000. By the way, what if it would have been a negative? Whew. It would have been negative 10. Okay, next one. The fifth root of negative 32 is negative 2. And the reason is because negative 2 to the 5th is negative 32. Just to make sure we all understand when these negatives will and won't work out. What if we were asked to do the cube root of negative 27? Well, what's the answer? Negative 3, because of the same reasoning. Negative 3 to the 3rd power is negative 27. But what about the fourth root of negative 16? Is that negative 2? And the answer is no. This is not true because negative 2 to the 4th, how much is that? Positive 16. Which is why if we were asked to do fourth root of negative 16, we would say not a real number. Okay. Now what you could do is you could do a complex thing. You could take out an I and everything else and all that stuff, but it's not going to generally be done all that much. So we can address that in a different video. Alright, cube root of 54, x to the 12th, y to the 5th. Now here's the trick on this. Why did this work out so nicely here? Because x to the 6th divided by 2. You were doing a square root. So the 8 divided by 2 and got 4. The 6 divided by 2 and got 3. What are you going to divide by this time? We're going to divide by 3. That's why we're going to rewrite this. 54, we're going to put that as 27 times 2 because 27 is a what? A perfect cube. Alright? Now, this is your 54 right here. Okay? X to the 12th just stays just as it is. But then the y to the 5th, look what we do here. We write it as y cubed times y squared. And we do that because the 3 will divide by 3. So look what you got here. Cube root 27 is 3. Cube root of x to the 12th is x to the 4th. Cube root of y cubed is a y. This is going to be y to the 1st. Okay, this 3 here belongs to this cube root. Okay, and I made it a little more obvious in the answer here. Now, why is this inside here? Because guess what? Those were the two parts of the problem that were not taken the cube root of, so we left those in here as 2y squared. Okay, so bam, there's your final answer. 3x to the 4th y times the cube root of 2y squared. Next one, and the last one of this video. Fifth root of 96, x to the 12th, y to the 5th. We're going to be fancy here again, and we're going to rewrite the 96 as 32 times 3. Okay? 96 is 32 times 3. So you just rewrite it. Again, why are we doing that? Because 32, if you take the fifth root of it, you get 2. Okay? X to the 12th can be written as x to the 10th y squared. Why am I doing x to the 10th? Because we want to eventually divide by 5. So this one's all set, so we're in good shape. So there's your 12th right there. Now, 5th root of 32, 2. All right, 5th root of x to the 10th, x squared. 5th root of y to the 5th is a y. What did we not do? We didn't do the 3. We didn't do the x squared. Those are left over. There's your final answer, and you're a happy camper. Okay? So, guys, this is Simplifying Radicals. Good times. Thanks for checking out the video. And, of course, if you have any questions, send me an email. Talk to you later.